Good evening, everyone, and welcome back to day 2 of Field Familiarization Program for the 24th batch of Faculty of Engineering, University of Moratul. Yesterday, we explored the worlds of electronics and telecommunication, civil and chemical and process engineering with the help of some truly inspiring souls. We hope those sessions sparked your curiosity and gave you clarity as you begin thinking about your future specialization. So, today we continue our journey with 5 more exciting fields that each bring unique opportunities and challenges. Whether your passion lies in circuits, machines, materials, computing, or healthcare innovation, there's something today for everyone.
Let's begin this evening with a discipline that quietly powers almost every branch of engineering, material science and engineering. To give us a well-rounded view of this essential field covering both the industrial applications and the research frontiers, we are delighted to welcome Ms. Shana Vijayaratne and Mr. Pulinda Kasun, both final year undergraduates from the Department of Material Science and Engineering at the University of Moratul. Ms. Shana Vijayaratne currently serves as a Quality Assurance and Quality Control Engineer at Trinity Steel Private Limited, ensuring quality in a demanding industrial environment. She has also contributed to innovation as a research and development trainee at Cable Solutions Private Limited. Her time at university has been enriched by leadership roles such as event committee member for EXMO 2023 and secretary of the Mora Cinema Society. She was also actively involved in the Material Engineering Student Society. She was also part of the Mora Hiking Club, Drama Club, and SEDS Mora. Mr. Pulinda Kasun brings a strong academic and research background, having earned a place on the Dean's List for 6 consecutive semesters. As an undergraduate student researcher, his work spans projects including the design of an electrophoretic light scattering-based instrument, the demonstration of Bravais lattices, the investigation of two-particle sintering models, the design of aluminum extrusion dies, and developing a PCM thermal storage system for greenhouses. He has also gained hands-on experience as an engineering trainee in research and development. With Ms. Vijayaratne sharing her insights from the industrial side and Mr. Kasan presenting the exciting research opportunities in the field, we are set for an engaging and informative session. Let's warmly welcome Ms. Shana Vijayaratne and Mr. Pulinda Kasan to the spotlight.
Am I audible?
Oh, yeah,
Yes,
I know.
So Shana will join sometime later. So I'll start the session and she will continue on the industry part, and I'll continue on the research part then. So am I audible enough? Is there a problem? And also, can you see my screen?
yes, I.
So basically, good afternoon, everyone. So it's a real privilege to actually talk about the Department of Material Science and Engineering. So material science and engineering is kind of among state universities. So learning about material science and engineering, like mechanical engineering, electronic engineering, electrical engineering, likewise, because it's kind of not like a real engineering discipline that you can see in day-to-day life, but it plays a huge role in our day-to-day lives, designing, fabricating a lot of materials for various engineering applications. So basically, our department has originated as Department of Material Science, actually, under the Applied Science domain in Hatupattu campus, University of Ceylon, with only 5 students as a initial intake, but it has increased up to like 50 students now. So now actually it is named as Department of Material Science and Engineering. So it's kind of like computer science and engineering. So we have a science background and also an engineering background. Because actually to work as a material engineer, to actually study material engineering, you need some background in material science. So material science is actually coming from a lot of other backgrounds like physics, chemistry, biology, and other disciplines. So basically, we have a well-rounded academic staff. We have 3 professors, and also actually most of our staff are PhD holders, specializing in electroceramics, solar cells, spectroscopy, optical materials, photonic materials, metallurgy, polymer science, in all the disciplines that you can see in material science. So basically, material science and engineering is a very vast discipline. It's a very kind of like a versatile discipline. Everything you see in engineering purposes, you need to use a particular material. Maybe it's a metal and alloy, ceramics, polymers, composites, semiconductors, biomaterials, and so there are so many other materials. So in materials science and engineering, we study these materials, but definitely you see that more there's a huge sum of materials that we need to study, and actually we are not specializing, or all of our graduates are not specializing in all these materials. Actually, we'll get a basic understanding, basic introduction to all these materials, and basic theoretical and practical understanding both sides. But then from semester 5 onwards, we'll be specializing in a particular type of material. Like some people are moving towards metallurgy, studying metals and alloys. Some people are moving towards ceramics, polymers, depending on their interest, basically. So if you kind of like meet somebody, on a bus, and let's say they told you that he or she told you that he or she is a materials engineer, material scientist, and if you ask him or her about what he or she is doing or something like that, and definitely the answer will be pretty different from one person to another person, actually. Because the things that we do as material scientists and engineers are different from these different kinds of materials, basically. So it's very important to understand that. And so it's kind of like, a very vast discipline, facilitating a lot of engineering disciplines. So basically, if you look at material science and engineering, it's all about this particular material tetrahedron, actually. You start from performance. You need performance for different engineering applications. So you look at material performance. So you want to increase the material performance. To get that, you may need electrical properties, magnetic properties, optical properties, mechanical properties, a vast range of properties. So to do that, you need to tailor the structure of those materials. To get that structure, you need to process the material in a particular way, actually. So sometimes you might have heard about the crystal structure and other phenomena. So all those things are, related to the material tetrahedron. So some people are actually working in processing structure relationships. How the processing changes the structure of material. Some people are actually looking at structure property relationships. They are looking at, how we can get the desired properties by changing the structure. Some people are actually looking at the material selection side, the property performance relationships, basically. So, and all these things are kind of like, rounded by characterization techniques. So there are different characterization techniques that we need to use to, look at the materials, look inside the materials, like scanning electron microscopy, transmission electron microscopy. Lot of techniques are there actually. So basically, our curriculum depicts in all these segments basically. So semester one is kind of a common semester, and then onwards, up until semester four, we get kind of a theoretical background for all the material segments. So for that, basically, we need thermodynamics, material thermodynamics, material kinetics, especially solid state kinetics, including especially diffusion, quantum mechanics, solid state physics, and other design modules, and also mathematics basically. So you see, we get to know about fundamentals of materials and engineering, like the crystalline structure and the extension of the crystalline structure, Bra lattices and other stuff in fundamentals courses and in thermodynamic courses. Then we get some introductory electrical courses from CS courses from other departments. Then actually we look at some metals, polymers, ceramics, and then onwards, actually, from semester 5 onwards, we look at specific types of materials. Basically, either it's maybe biomaterials, construction materials, electronic materials, semiconductors, metallurgy, ceramics, advanced ceramics, materials modeling. A lot of segments are there. Composites, smart materials, magnetic materials, optical materials. There are a lot of materials. So then basically within our department, we have two focus areas. Focus area in polymer engineering and focus area in electronic materials engineering. So basically, people who are going into polymer side, they want to do these polymer engineering modules like latex science, industrial polymer process engineering, dies and design, most for polymer processing likewise. But if you want to go to electronic materials and also other segments of electronic materials like optical materials, magnetic materials, you need to actually do electronic optical device engineering, electroceramics, smart materials, and magnetism and magnetic materials for device engineering. So basically, within our curriculum, we'll be talking about material thermodynamics, solid state kinetics, quantum mechanics, solid state physics. And if you want to move on to magnetic materials and optical materials, you need to have a quite sound understanding about electrodynamics, like Maxwell equations and other stuff. So if you want to go to magnetic materials and optical materials, actually you need to look at electrodynamics. So you will be learning electrodynamics if you want to move into that side in the curriculum. So basically, there are several basic materials, polymers. So there are several modules assigned to understanding polymer materials. So there are a lot of industries as well. So Sean will talk about the industrial sides, basically, under polymer science and engineering. So basically, we will be looking at a lot of polymer modules because, there are a lot of polymer-based industries in Sri Lanka, either in tires, paints, gloves, cables, a lot of things are there actually. And then metals and alloy side. So a lot of our interns and our recent graduates have gone to metal side as well. So there are some industries in Sri Lanka as well, like Michelin, casting, and other things. So basically, nowadays it's not just about just simple metals. It's also about alloy. We get different properties by alloying the metals, different metals. with different compounds as well. So with that, actually, we get different enhanced properties for aerospace applications, automotive applications, maybe structural nuclear applications. A lot of things are there. So we'll be covering, some modules on how to alloy the materials and how we can actually, change the properties of materials by alloying. And then ceramics. So most of people think that, when we say ceramics is all about like, cups and mugs and jugs and all these things, tiles, ceramics is not only about those things. Nowadays, actually, people are moving towards advanced ceramics. So there are piezoelectric ceramics, pyroelectric ceramics. So there are a lot of different ceramic materials. They are called advanced ceramic materials. So most of the sensing applications that you see come from these ceramic materials actually, the most of the sensors that electronic engineers use, like, maybe it's proximity sensors, IR sensors, a lot of sensors, they come from ceramic materials. Ceramic science and engineering applications are there actually. And also, you can actually, kind of categorize glasses under ceramic materials as well. But, there are some differences, but people, tend to categorize glasses under ceramics. So there are a lot of glass applications. Nowadays, actually, with smartphones and other, glass-based structural applications are there a lot. You see that nowadays there are a lot of buildings filled with glasses, not concretes, because of lighting and other purposes. So there are a lot of new glass coming, from a lot of industrial giants like Corning. So then actually one of the most emerging fields is actually electronic and optical materials. So we have semiconductors, optical devices, magnetic devices, solar cells, a lot of things are there. So basically, if you look at semiconductor fabrication, materials as an engineering plays a huge role in semiconductor fabrication. So electronic engineers, electrical engineers will be actually kind of like designing the PCs, designing those ICs, but how to fabricate those things, how the material properties, change during this fabrication process. And, you see that nowadays we have, 3 nanometer technology. So when we have like 3 nanometer transistors and other components in ICs, there are a lot of failures actually. So, there's one seniors, passed out from our department who have been working in Intel, actually figuring out these failure modes in ICs and other components in Intel, Oregon. And solar cells is also a very, kind of like a fastly emerging material science discipline. So people are looking at perovskite materials for solar cells. Organic materials are there. So there are several final year projects are there as well, under organic solar cells and other things. And also optical and photonic materials. Nowadays also we are moving towards optical circuits. So that is basically an electrical engineering this domain, but actually to facilitate photonic material, photonic side, you need optical materials basically. To develop optical materials is a material science domain. I did my final year projects under optical materials basically. So then actually, we have nanomaterials. So when you talk about nanomaterials, we have ceramics under nanomaterials, polymers, a lot of things are there. Nanomaterials. So we see some very kind of like there are nano coatings, nano garments are there. So there are a lot of day-to-day applications, but actually there are other things that are coming into the research domain like nano drugs, drug delivery techniques. So some of the parts in these applications are material science based things. So then biomaterials and construction materials. So from hip replacements to ear implants, then medical stents. So we use, shape memory alloys for medical stents. So in developing a lot of biological application-based implant-based materials, biomaterial play a huge role in material science nowadays. So most of our current graduates have gone to higher studies in biomaterial segment, basically. Some people are actually looking at drug delivery based on nanoparticles. Some people are looking at 3D printing of biomaterials. A lot of things are there. And construction material is a very hot topic in Sri Lanka, actually. A lot of job opportunities are there in construction materials. So there's a one module specializing in construction materials. So then, as I mentioned earlier, our materials as an engineering have applications in all the engineering disciplines. We have applications in uh, electronics, electrical engineering, mechanical engineering, and civil engineering, basically. So to facilitate some of those engineering applications, actually the materials developments, material innovation should be there. Without the material innovations, you cannot actually do some of those applications basically. So you see that, computer chips are evolving from 5 nanometers to 3 nanometers beyond. And most of these things are there because of material science applications. And nowadays we see 3D printing. So you can actually build a 3D printer, with basic mechatronic knowledge, electronic knowledge. But to actually, to understand how to 3D print the material, like, the 3D printing process, how the material is processed, how these properties are changed during the processing techniques during 3D printing. You need to study those things. You need to develop new materials which are compatible and also have higher strength and other properties, desirable properties. So material science plays a major role in 3D printing applications, actually. You will see there are a lot of guys working in 3D printing based materials. And also, electronic materials are there. And also, if you come to materials as an engineering, actually, nowadays people laugh at saying that you can actually do CS. So, we used to do material selection for different material applications. So we have very large material selection charts, material databases. So when we want to choose a particular material for a particular application, what we needed to do is to define the properties related to the that in particular engineering application. Then define material indices. Then go and look at material selection charts. But nowadays, the material informatics have come into action. So we don't need to actually go and look at those things, and people are working at these levels, material informatics. And we had several final year research projects, specializing in this material informatics section, using machine learning for material innovation. Some of those guys were working on solar cells, material composition, based on machine learning. Some of those guys are working on machine learning based optoelectronic materials and also material selection. So I'll be talking about those things later. Then there are a lot of equipment and facilities at our department. We have an analytical laboratory with SRD, TGA, infrared spectroscopy, fluorescence spectrometer. I don't think that you will recognize the potential of these instruments, but they are all of the material related facilities are there. Most of these things are there at our department. So there's a pyramid laboratory, different instruments, material processing laboratories there, foundry lab is there, microscopy lab with the same optical microscope, fluorescent microscopes, polymer lab is there, textile lab, heat treatment lab is there. Heat treatment is a very important material process in most of the materials, like ceramics, electronic materials even. So I think Sean will continue on these different career opportunities. So I will actually talk about the research side. So we see some of the final year research projects at our department. So even though we are a very small department, we have quite a large number of final year research projects in different disciplines. Basically, you see a development of sustainable cement-based material for additive manufacturing. Those guys are working on actually making a 3D printing, the material for 3D printing, sustainable cement-based material for 3D printing. And some of those guys are working on sustainable materials using waste, dust, and nanomaterials, nanofluid applications, and piezoelectric material-based nano generators were there. And this is a machine learning based project. So this was my design, my final year project. So we actually developed a surface plasma resonance sensor by actually modifying a fiber optic and applying a thin nano level gold coating. And surface plasma resonance is a very hot topic nowadays. So you will, if you have time, if you have interest, you can go and search it. Plasmonics is a very hot topic in photonics, optical engineering, electrical engineering, all these disciplines. So our material engineering actually facilitate those innovations by actually material innovations basically. So most of those innovations are stuck there at the conceptual level because we don't have materials for those applications. So if we had those materials, we would be definitely, those other guys who are actually using those materials for those applications. But we cannot do that right now because we don't have those materials. Some of those concepts are there, in the sky, basically, not in the real world because we don't have the materials. So then the paints were developed, some of those. So some of those were based on composite materials like this. So basically, when you talk about research opportunities, there are quite a lot of research opportunities are there in material science and engineering. You can see energy and renewable engineering materials. So nowadays, actually, renewable engineering is a quite hot topic. So people are actually looking at how to enhance the efficiency of those solar cells. So to do that, actually, people are talking about perovskite materials. So can you see my shared screen? Is there any problem?
No,
Yeah, can you see my shared screen?
No,
no, we
we
can't
can't.
see.
Is it okay now?
Yes, I.
Was it there for a long time? Or is it just isn't
No,
it?
just a bit type.
Yeah. Okay. So now people are looking at perovskite materials. Then organic solar cells are there using lead-based stuff. And people are actually looking at removing those lead-based stuff and move into other sustainable materials as well. All these things are basically material science innovations. So for some of those things, we need physics knowledge. Some of those things we need chemistry knowledge. Actually, we take those knowledge from those disciplines and we develop materials. And nowadays, computational and data-driven materials engineering is also a hot topic because uh, in selection of materials and when you want to tailor the particular composition of a material and you want to see the properties of the material, we used to that is kind of a research segment that we are working on. So that is kind of the structure property relationship. So we change the composition and we look at the properties, related properties. So that that study used to take around like several years, like 10 years ago, 20 years ago. But nowadays, actually, there are people working under material informatics who are looking at actually, predicting material properties by machine learning techniques. So that is actually a quite fascinating area. And sustainable and green materials, civil and engineering, structural materials engineering is also a very quite interesting one. And people actually, a lot of people have gone to higher studies based on that. Aerospace materials are there, like if you saw that SpaceX launch, and also that spacecraft went up to space and then came back. And when it came back, the outer skin of that spacecraft was like under flame. So designing these kind of materials under extreme environments is also a hot topic now. Metamaterial is a very important topic. We have several intrinsic properties for materials. But actually, for an example, in normal materials, we have positive refractive indices. But we can design metamaterials with negative refractive indices, negative Poisson ratios, actually. So metamaterials are basically on nano structuring and other things. There are also quantum and topological materials because of quantum computing. In quantum computing, we need superconducting junctions. For that, actually, we need material science-based applications are there. Material science-based innovations should be there actually, basically, to actually enhance the efficiency of these things. Biomedical, bioengineering materials, they are also very hot topic. Nanomaterials, functional materials, and chemical engineering, optical, photonic, and electronic materials. All these research opportunities are there basically. So people have gone to all these universities from for higher studies from our department basically. So you see universities in the US, UK, Australia, Canada. So basically, we have a quite good fellow, Dr. Isuru Karunaratne. He was working under, biomaterials basically in Noah Hart, Hong Kong. So, and also Dr. Janit Munagolla is also under 3D bioprinting. So he did PhD in University of Toledo, then went to California Riverside and Rhode Island. And we have process engineer at IQM Quantum Computers, Finland. She's actually a nanofabrication engineer there. So we have other graduate students. So basically, then to talk about industrial segment, I invite Shanu. Shanu, are you there?
Yes, please, I'm there. Can you hear me?
Yeah. Then I'll share the screen. Then you can continue. Yes, sir.
Okay.
Right.
Hello, good evening. First of all, I would like to thank giving me this valuable opportunity to do this field familiarization session. So my name is Shanu Deshika Vijayaratna, and I'm currently working as a QA and QC engineer. So today I want to give you a clear picture of opportunities you have and how to prepare for them, like what this field really offers and the type of the jobs you can aim for, and my personal journey and the lesson learned, and how you can prepare yourself for success. So first I move to tell what exactly is material science and engineering. It is a science of understanding, developing, and the improving materials. So it is the study of how materials are made and how they behave and how we can improve them to meet the world needs. So materials are anywhere from the steel in the bridge to the polymers in packaging and the ceramic in the electronics. And not only that, and the nanomaterial also in the medical device. So there are so many opportunities in this material science and engineering side. So material science and engineering degree, it is doesn't lock you into single path. Actually, it open doors in the multiple industrial, and it's basically depending on your interest and specialization. And you can work as like slide shows, production engineer, process engineer, and also quality assurance engineer. Then you can move to research and development side, and also material data scientist and material engineering. When we talk about this production engineer, he is the make sure product are manufactured efficiently and on time and with good quality. And the process engineer also design the product and also testing side and improve the process. Uh, when the quality assurance engineer ensure the product meet standards and the customer requirement. So through this material science and engineering degree, we have lot of job opportunities actually. Uh, in Sri Lanka, fresh graduate salary can start around 140 lakh with higher pay in specialized and in various company. And when we talk about overseas opportunities, it can be much higher depending on your skills. And in here in this material science and engineering degree, you have the freedom to choose your focus area based on your interest. And you can also combine multiple area like in the previous slide, I think in the no other one. Yeah, this one. In this slide, you can show some of the companies where you can apply if you want to work in the polymer field. And I think polymer field, yeah. This include in like industries like packaging and the rubber products, plastic, and the composite, and many more. So if you're interested in the polymer side, these are great places to start your career. And after in the other slide shows, if you like ceramic field, ceramic metallurgy and the smart material, you can go through these companies with your fashion. So the other one of the big advantage of our material science and engineering degrees is that doesn't only give you technical knowledge and knowledge about metal, polymer, ceramic, and nanomaterial. We also get exposure to industrial level skills like ISO standard, quality management system, and the sustainability practice. These skills are highly valued by employees both in Sri Lanka and abroad. When you graduate, you won't just have subject knowledge. You will have skill set that directly match with that company needs. So you have great opportunities with our degree side. When I talk about my journey, I studied all these subjects, but I focused more on polymer. In my final year project, also done with polymer side. So, however, because of I had strong knowledge in metal and steel, I secured my first job in steel sector as a trainee steel company in Katunayaka. And other thing is, some people think steel industry job are not for a woman, and the companies don't hire female engineering for heavy industries. Actually, this is simply not true because I am a proof that if you have the knowledge, skill, and the confidence, you will get the job. So, when I talk about my job opportunity and about my job, it is a quality assurance and it is a ensure product are safe and the reliable and meet customer expectations. So the field combine technical skills with the problem solving and team working. And these QA and QC professionals play a key role in the improving process and preventing defects. So in my career, I enjoy my life and I get lots of things to my life. And other thing is, other bad thing is people might speak negatively about our degree, uh, saying it hard to get job or not worth it. But here is my truth. I think if you truly want something, you can achieve it. Definitely, you can achieve it. And the other thing is, our academic staff is very supportive. More than other department, they guide you not only the academically, but also personally, they guide you. So I think uh, in our final semester also, the workload gradually reduce and giving you more space to prepare for your career and high studies. So I think if you select the material science and engineering, you can make your life better with better path with our degree side. And also, finally, I like to give you some idea about our events we conduct through our annual event like Hasarella. I think it's fine. It's like, yeah, we annually do some events like Hasarella program and the MSc Career Day. Through that, we connect our student with top companies, and the other one is our symposium event. And finally, we do some annual get together and the cricket festa. And now we start the Avasaka Havasak event to give some social evening to and relax and connect with the friends in the department. So these are our final of our this session, I think. So if you have any question, you have the chance ask any question with us. So thank you.
So there's one question for me. There are related modules for quantum technology in course. So there are several courses. Basically, in solid state materials, you will be learning about basic quantum mechanics from like Schrodinger equation and how to apply Schrodinger equation for infinite quantum well, from there to simple harmonic oscillator and there to variation principle, and you will actually study all physics related quantum mechanics under the module. Then you will see that from that knowledge you get from quantum mechanics, then you can move on to study solid state physics. So to study solid state physics, you need quantum mechanics actually. So then actually the solid state physics is the foundation of material science. So under solid state physics, you will be actually looking at Bravais lattices in more depth, historiography in more depth. And also some material properties like piezoelectricity, ferroelectricity, and other material properties in more depth, basically. And also you will use the quantum mechanics based, theory in other modules, basically in magnetic materials, basically to study ferromagnetism and other magnetic properties. You need quantum mechanics. So basically, so there's a huge portion in quantum technology, quantum mechanics in our module. So if you want to go there, you can. So basically, you need a quite good understanding about mathematics, math modules. So you need to get the math knowledge, and with that, actually, you can go beyond even physics graduates. So the next question is, if I want to innovate on computer hardware, quantum computing, should I choose EMTC or MSc? So that basically depends on what you want to innovate, basically. So when you actually talk about a particular engineering innovation, there's not only one discipline playing a role. So for an example, also in semiconductors, that is there. Semiconductor fabrication is material science based application. Basically, you want to look at the material design. So the lithography process, and when you do the lithography process, how the material, the grain boundary changes, and all these things, how the crystalline structure changes. Those things are there. So then solid state diffusion is also, it should be used. But when you want to go to like IC fabrication, IC design, then you need to look at electronic and telecommunication engineering. So that is, where do you want to innovate? Basically in quantum computing as well, there are quantum computing designs. There are basically like several algorithms are there. So if you want to like do those algorithms, basic design, you need other fields like CSE, ENTC, or electrical. But if you want to go and look at the material side, what facilitates these things, you need to come to MSc. So in quantum computing, we have like superconducting junctions are there. So superconducting junctions, and nowadays we are talking about high temperature superconducting, and those superconducting junctions should be well efficient to actually facilitate quantum computing for a longer period of time. So people are actually looking at these things, basically in quantum computing and material side. Then those materials innovations are used in other applications, in other engineering disciplines, and you get the quantum computer basically. So I think you might have got my some understanding. So it's not only about ENTC, it's not only about MSc, not only about CSC, it's a combination basically. So you get the material, you design junctions with various materials and look at the performance. Then you use those things to design the quantum computer. That's a computer architecture thing actually. That's electronic electrical computer side. Then you actually design the algorithms. So for that you need CSC. So it's not about only about one discipline. So there are actually people who are working in CERN on the material side. A lot of material science based applications are there, because in CERN, you look at how materials behave under different new conditions, especially in nuclear side. So you can actually go and look at material science used in CERN and look at what are those applications basically. Uh, when considering biomaterials, does it also include biotissue and regenerative medicine? And what are the paths you want to study and pursue in quantum chips? Because EMTC students study that too. How different is that approach? Yeah, that approach is different because that you look at the computer architecture, the quantum chip architecture in ENTC, but you do not go much deep into the material side. If you want to go to the material side, that requires you to look at solid state physics, quantum technology, some parts, and also solid state kinetics and other things are there. So you then also some other principal quantum crystallography and other things. So if you want to go to material innovation in quantum chips, you can do that. And also if you want to design the architecture of the quantum chip, you can do that with ENTC actually. So in biomaterials actually, there are a lot of biomaterials, a lot of biomaterial applications, biotissue based applications and regenerative medicine are there. There was one PhD student at North Dakota State University looking at regenerative medicine, and now he is working in FDA, Federal Drug Administration in the US, basically as a postdoctoral fellow. And actually, another guy is working at University of Delaware. He's working in biotissue, basically. So basically, there's a biomaterial-based module for that. So do we need to be genius in the programming language during the course? You don't have to be it also depends on which side you are going towards. Basically, if you want to go to material informatics, you need a sound knowledge in programming languages. Actually, we need to thank ENTC for that. There's a quite a good machine learning courses available at ENTC. So people who want to excel in material informatics can get AI ML knowledge from ENTC department from those modules. I think there's a minor in pattern recognition. So many people did that in our department, and they did machine learning based final year projects. Basically, I talk that things. Very good. So, but if you want to like in normal engineering applications, it would be better if you can just use Python or MATLAB. Those things are very useful in a lot of applications. Basically, especially when you are doing FIP, you don't need to be doing ML or something, but you need to be somewhat familiar with basic programming. Basically, semester one programming is enough sometimes, and then actually you can build on that using other tutorials. So I'm interested in creating something new related to nano. To be exact, interested in nanotech. Will this field give me the correct exposure to that field? I'm confused whether to go with mechanical or material science. Can you please give me a sort of clarification? Yeah, nanotechnology is also something, as I mentioned earlier, is also a lot of fields are there for nanotechnology as well. So the basic foundation nanotechnology comes from nanomaterials. So the basic foundation for nanotechnology comes from material science. And there are applications in electrical engineering, mechanical engineering, electronic engineering, chemical engineering, even civil engineering are there. But basic material, nanomaterial side is material science. So for an example, I'm doing a master's, research master's. In my research master's, what I'm doing is I'm looking at how to confine plasmons in nanoparticles. So that thing can be used for other biomedical applications. So to study that nanoparticle interaction with plasmos, that is kind of a material science plus electrical engineering scenario. Then using that is biomedical engineering. And also there are like nano electromechanical and micro electromechanical systems are there. So there are like gears and other stuff designed in nano level or micro level. Using that is mechanical engineering, designing those things, because they are just the the micro level stuff, that you can see, you can see large gears and other stuff. Like we can design all these things in micro level or nano level. To do that, to process those things and to do that, you need material science. But to design these things, like the how to position that gear in this place, that gear in this place, like those things, you need mechanical engineering knowledge. So in such a project, you need mechanical engineers, material engineers, electrical engineers, all these people. So if you want to design the material part, how the material behaves, you have the material engineer. If you want to design the gear system, you have mechanical engineers. Now for some other applications, you need other engineers, basically. So I think I answered the question as well. So as I mentioned, in all these things, I can give a very short answer for all these questions. The material science and engineering is a very versatile discipline. It facilitates all the disciplines, because in all the disciplines we need materials. Some of the advancements or some of the achievements are not possible because the right material is not there right now. For that, we need to design that material. We need to invent that material. For that, we need material science and engineering. From that point onward, to use that material, that is that engineering field, basically. So this kind of material science and engineering is kind of facilitating field, basically. You can go to any industry if you want. You can go to, like, if you are really good, you can go to spaces and look at aerospace materials. If you are really good, you can go to jet propulsion laboratory. If you are really good, you can go to Intel and look at the semiconductor fabrication based materials. Like, you can go to any industry. You can go and look at structural materials and design meta materials for structural based applications in civil engineering. A lot of things are there. You can go to any field, basically. That is not something that is possible with other engineering disciplines. People can go to any engineering discipline, and any engineering discipline can come and work with materials as an engineering, because it's a facilitating discipline, basically. So, Shanu, is there anything you want to add? There's a question for Shanu, I think. Are there jobs in Sri Lanka related to material science? Shanu, are you there?
Yeah,
Are there jobs in Sri Lanka related to material science? These questions are directed to me. I think
I think I totally answered that question.
do you want to add something for that, Shanu?
Yeah, I have one more thing to add. I want to tell something. Actually, when I first entered the material science and engineering degree, I didn't have perfect academic start because my first semester GPA was 2.23. So I want to tell, I had one important thing because I interest in the field. So I didn't give up. So I work hard. I improve step by step. And by the last semester, I even made it a dean list. So I want to tell you, don't upset with your GPA. So it's upon to you. If you interest on this field, you can make it. I think this is my last thing you that tell to you, and don't give up. Actually, it's not depend on your GPA.
Yeah, there's another question. Is it required to get masters or PhDs to get higher salaries in this field? Is it enough to do research and innovate with this degree related to materials? I think there are a lot of jobs without masters. I think, Shanu, but masters will actually
Sorry,
elevate you.
sorry, I didn't clear. Remember.
Yeah. Is it required to get masters or PhDs to get high salaries in this field? Is it enough to do research and innovate with this degree related to materials?
No, actually, it doesn't need the MSc degree for our high salary. For high salary, within this degree, we have get salary around like I said like around 140 lakh. If you have any idea to do some MSc degree, it is more advantageous to your future, but it not depending on your first start, I think.
Yeah. And also I need to add something. So there are some fields you need these PhDs. Basically, for an example, if you want to go and look at like quantum computing based materials, then definitely you cannot even talk about these things in PhD level. So maybe in PhD level you have just scratched the quantum computing based materials. Then you need to then go to postdoctoral levels, basically. So with a bachelor's degree you cannot actually work with quantum materials. Basically you cannot do that. You need a higher degree for that. So for some applications, you definitely need higher degrees. But for other general engineering applications, definitely you don't need that. For some specialized things, for specialized applications, you need advanced degrees. That is also true for other engineering disciplines as well. For CSC or other Indian discipline, if you want to do advanced stuff, you need advanced degrees basically. So there's another question. So is it? So all the questions are coming to me. So as a direct messages. So you can actually send it to all these questions. How How is the academics in the material department and what we will learn? Where can we get internships from in the third year? What the projection toward the future if you follow material engineering, salaries, career growth, abroad countries, companies that we can work for? An idea about the aspect of entrepreneurship. I think we talk about these things, Sham, isn't it? So in the slide, if I go to the slide again, in the first couple of slides, we talk about what we learn in material science and engineering. First of all, we learn about material thermodynamics, solid state kinetics, quantum mechanics, solid state physics, uh, basically those things as theoretical aspects. So then we talk about different material-based technologies, and also some mechanical behavior modules are there. So we talk about metals, polymers, basic applications are there. Then from semester 5 onwards, you need to specialize in particular material, basically. Maybe it's metals, maybe it's polymers, maybe it's electronic materials, anything. Maybe it's construction materials. So salaries, I think Sean mentioned salary scales. So the question, the next part, but you can actually get internships from a lot of different industries, as Shanu mentioned, from all these industries. So I think most people have actually got internships from these industries. I got internship from fintech. So these are the available industries there. So the projections are either academic projections are there. You can work in research, or you can go to industry basically. So there are opportunities in other countries as well. So you might have heard about 3M, DuPont, Applied Materials. 3M, DuPont are very famous ones, and there are Morgan Advanced Materials. Corning, you might have heard about Corning Gorilla Glass in Samsung iPhones. Corning is actually a very highly advanced glass manufacturer in the world. It is based in New York. Can I access past FYP projects? You can access in our department website, basically. So there are some, these are some final year projects in batch 20, the recently graduated batch. So if you are interested, actually, you can actually contact the faculty if you want. You can contact through instructors or whatever the way, and talk about what they have done in those FYP projects. And there's a symposium coming up. You can go to the symposium and look what they have done. So yeah, that's so if you are interested, actually oh, sorry, I have muted. So if you want anything to be clarified, you can contact me with this number.
Thank you so much, Ms. Shanu Vijayaratna and Mr. Pulinda Kasum, for that engaging and insightful session. Your journey and experiences truly highlighted the importance and versatility of material science and engineering in shaping the world we live in, from infrastructure to innovation.